With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question given here is hydrazine, which is N2H4, act as a reducing agent. To prepare 100 ml of 2 normal of hydrazine solution, the weight required will be, since hydrazine, which is N2H4, is a reducing agent, so it reduces other compound and itself oxidizes to N2. Here the oxidation state of nitrogen can be calculated as, let the oxidation state be x, so 2x minus 4 will be equal to 0 and x will be equal to plus 2. Oxidation state of nitrogen in N2H4 is plus 2 and oxidation state of nitrogen in N2 will be 0, is 0. So the change will be of 2, but there are 2 nitrogens, so change per molecule will be of 4. Therefore, valency factor is equal to change in oxidation state per molecule, which is equal to 4 change in oxidation state per molecule, which is equal to 4. Okay. Normality is given, which is 2 normal we have to prepare. So normality is equal to number of gram equivalents upon volume in ml into 1000, because we are taking a volume in milliliter, and number of gram equivalent can be calculated as number of gram equivalents is equal to given mass upon equivalent mass, and further equivalent mass is equal to molar weight upon valency factor. Equivalent mass is equal to molecular weight upon valency factor. Valency factor is 2, therefore we have calculated above, so equivalent mass will be equal to 32, which is molecular mass of N2H4 upon 4. Okay. So now normality, which is given in the question, equal to 2. So 2 will be equal to number of gram equivalents, which is given mass upon equivalent mass, and we have to calculate the mass. Let's call it m. So m upon 32 by 4 into 100 into 1000 is equal to 2. So on calculating, we get m is equal to 1.6 grams. This is the mass required. Option B is the correct option.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.